All right, guys, the second, or actually third set of topics I want to talk about in this unit are what's called binomial probability, which is a really messy formula, but our calculator does it for us, so we are in luck. And then we're going to talk a little bit about some stats today. We're going to talk about the measure of center and variation and how to do those on our calculator. And we're going to finish up with box plots, box and whisker plots. All right. So the first topic is binomial. Binomial experiment is anytime you have an experiment where you have an equally likely chance of no, it doesn't have to be. Yes. Okay. Let me try that again. There are only two outcomes. Okay. That's what makes it binomial. Success or failure. For example, it rains or it doesn't rain. You get a hit or you don't get a hit. True or false. You guessed right or you guessed wrong. There have to be two possible ways. Success and failure. Okay, the probability of success is P, and that has to be the same on every trial. Okay? If it's not, you can't use it. It's not called a binomial experiment. And the probability of Q failing is also the same on every trial, which Q would simply be 1 minus P. So the probability of success is P, the probability of failure is called Q, and Q is equal to 1 minus P, the complement. So the chance of randomly selecting a month 30 times and getting January, okay, would be 1 out of 12. Not getting January would be 11 out of 12. If we're selecting a card 100 times and you want a heart, there are 13 hearts out of 52. Is that what they want? I guess so. So 13 out of 52, or 1 in 4. The chance you don't get a heart would be the rest, or 3 in 4, the probability of not getting a heart. All right. So the probability doesn't have anything to do with how many times we're doing the experiment. That's another part of the question. All right, the definition of the formula is this, and you can write that in here if you want. You would say there's how many different ways. I'm going to use the variables we've used. Okay, we do NCR, and then it's the probability of success, R times, and the probability of failure the rest of the time. Okay? That should kind of make sense if you think about that for a minute. How many different ways can I pick a card? And what's the chance of success times the chance of failure? Okay? But our calculator is going to do all this nastiness for us. We are going to use on our calculator what's called binom PDF. And I'll show you where that is. I think I have it in a second here. So Mark tosses a coin 25 times. What is the probability that lands exactly 7 times on heads? So if we were doing the formula, we would say 25 times, and we want it to land exactly 7 times on heads. Well, the probability of heads is 1/2. The probability of failing is also 1/2, and that would be the remaining 18 times. Okay, so I'm going to type that real fast. If I did 25 and then I did alpha window and I went to choice 8 and I put in a 7 and then I did that quantity times, I should be doing this on here because you need to see this just once. Sorry. 25 alpha window choice 8, we're doing it 7 times, arrow to the right, 1/2 or 0.5 to the 7th, and then arrow to the right, and this one happens to be an equally likely chance that we won't get heads, and that's how many failures you would have, which is 18. Okay? Now, what we're going to learn is that we can do this in the binomial distribution. Binomial probability is a key here. It is in this distribution or vars. So it's second vars. And then it's shorter to arrow up. You can't use these, guys. We're going to talk about normal distribution tomorrow. But we're doing binomial right now, so you go to binomial PDF. Now, the newer calculators make this super easy. How many times are we doing this experiment? 25 times. What's the probability of success? 1/2. And you can put 0.5 there, it's fine. X is how many times do we want it to happen, which is 7 times. And then we just hit enter a couple times, okay? If you had an older calculator, you'd have to put these numbers in with commas. The comma key here is above the 7. And then it should be exactly the same answer. It did all those crazy calculations for us, okay? So let me put this back up and drag this onto our notes so you can see that. So we'll use the calculator this time. Do I have the calculator example in here somewhere? Here it is. Okay. It's the distribution key, and you have to arrow up or down until you find this. And we are right now talking about PDF. So make sure you don't pick CDF. So the binomial probability of exactly something happening exact number of times, exact number of successes. So the spinner is spun 10 times. What is the probability that lands on red exactly 6 times? So we're saying 10 trials, 6 we want to be successful, okay? The chance that it lands on red is 2 out of 8 spaces here. Is that right? 2 out of 8 is our probability of success. And you can reduce it. I'm just going to put 2 out of 8. And then you would say this binom PDF of, so when we go to the calculator, it's second vars to get the distribution. Up arrow is shorter, but you're looking for binom PDF. Make sure you pick the right one. And then there are this time 10 trials. The chance of success is 2 out of 8 or 1/4. And we want exactly 6 of them to work. So that probability as a decimal is this. And I guess I should talk about how they want us to answer these. In Delta Math, it will specify. Does it want a fraction? Does it want a percent? Does it want a decimal to a certain number of places? On these, I just did a decimal to 3 places. Sorry about that, guys. Okay. I did something wrong. There's only 6 spaces on this spinner. 1, 2, 3, 4, 5, 6. Oh, I should fix the video, but this is 2 out of 6. So this is wrong. Okay, let me stop it. This should have been 2 out of 6. So when you go here, we were doing this 10 times, but this should have been 2 out of 6. Only 6 spaces on that spinner. So it should have been 0.057 if we're doing 3 places. I'm so sorry. Let me put that on there. All right. This one says, Kate took a multiple choice test with 4 choices for each question. If she guessed the last 5 questions, what is the probability that she got exactly 3 of those questions correct? So the number of trials she was doing, she's guessing 5 times. We want her to succeed exactly 3 times. And there are 4 choices, one of which is right. So she has a 1 in 4 chance of picking right. So we're going to go binom PDF 5 1/4 3. And we get about 9%, 0.088 that would round to. Okay. So about a 9% chance that she's going to get that right. Where am I at on my notes? Okay. Chad randomly chooses a card from a standard deck 30 times, so he's doing 30 trials. What is the probability that he gets a diamond? Okay, so what's the probability of getting a diamond? The probability of diamonds is 13 out of 52, or 1 in 4. And we want him to be successful exactly 4 times. So we'd have out of 30, 13 out of 52, or 1/4, and 4 successes. All right, I'm just going to do it on my calculator here. So 30, 13 out of 52, or 1/4, and 4. I got 0.0604. Well, I did 4 places that time, but okay. There are 30 balls numbered 1 to 30 in a bag. One is randomly chosen and selected 12. One is randomly selected 12 times. So we're doing 12 trials. What is the probability of getting a prime number? Exactly 5 times. So this is our successes, would be 5. Now we got to figure out how many of them are prime. The probability is out of 30, we would have 2 is prime, 3 is prime, 5 is prime, 7 is prime, 9, it's not, 11, 13, 15, 17, 19, 21 is not, 23, 25, 27, 29. So there's 1, 2, 3, oops, yep, they're just 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a 1 in 3 chance that he picks a prime. So we would have binom PDF 12 trials. Probability of success is 1 in 3, and we want to succeed exactly 5 times. Is it 1 in 3? I already forgot. Yes. Okay. And so we get 0.191 if we round to 1 to 3 places. All right, guys, we need to get going here. The probability of customers at a store receiving a coupon printed in on their receipt is 1 in 8. If 20 customers visit the store today, what is the probability that exactly 3 of them receive a coupon? So 20 trials, probability of success is 1 in 8. We want exactly 3 to happen. So we do binom PDF of 20, 1/8, and 3. And I'm just going to copy this off my notes. Where is this question? And we get 0.230. All right. I'm just going to set up one more. In a game of chance, the probability of winning is 30%, so you would put in 0.3. 15 games were played, that's your number of trials. And the probability of winning exactly 6 games, you would type this in. Now, this comes out 0.147 I have. All right, the other possibility, that key that said CDF, okay, this function is exactly the same as PDF, except instead of a specific number of successes, like 3 successes, this gives you the probability that there will be 0 up to 3 successes, okay? So it takes and adds the probability of 0 successes, 1 success, 2 success, and 3 successes all together. So I am going to do number 10 first. It says, Carol randomly chooses a day of the week 6 times. So 6 is the number of trials. What is the probability of choosing Tuesday or Thursday? So there's 2 out of 7 days of the week that we're calling winners. What is the probability that she does this at most 3 times? So we could do this 6 2/7 if she picks it once. If she picks it 0 times, 1 time, 2 times, or 3 times. Those probabilities all added together, when we typed them in our calculator, would give us this answer. That's a lot of work. Okay, if you did Binomial PDF, you would have to add all these up. But there's a shortcut. You can do the combined probability of 0 to 3 times. And that's Binomial CDF for combined probability. And when you do that on your calculator, it looks like this. It brings up this little list that says, okay, it still says this, but you have to realize that it is combining all the probabilities up to 3 wins, 3 successes. So if we were to do at most 3 times, it was 6 2/7, and we wanted 3, up to 3. So we do 6 2/7, and we want it to add up all the possibilities, 0, 1, 2, 3. Now when we do it, we get this. Okay, it's 94. Let me show you real quick. If I were to do this as a PDF and put in 6 2/7, 0 is a winner, plus, okay, and then I were to go back up here and say I also want to add the probability that 1, once we win, plus, go back up here and add the probability that we win twice, plus, go back up here to this one and add the probability that we win 3 times. We get the same answer, but it was a whole lot easier to put it in as a CDF up here, which combined all of them for us. Okay, so it's 0.940. That's tricky. Now what makes it, I'm actually going to do, I think, number 12 next. There are 7 boys and 5 girls on the debate team. Each week, one is chosen at random to lead the debate. For the next 10 weeks, so 10 trials, what is the probability that no more than 4 girls are chosen? So what's the probability of choosing a girl? The girls are 5 out of 12. Probability of choosing girl. So we want no more than 4 girls. So we want the probability of 0, 1, 2, 3, or 4 girls. Anything above 4 we don't want to count as a winner. So we need to do the combined probability of 10 trials where the probability is 5 out of 12 girls and we want to pick 4 or less. No more than 4 is 4 or less. So we're going to go what happened here? Sorry. Combined probability of, I already forgot, 10 trials where the probability was 5 out of 12 and the number of successes was 4, but we want to combine them all the way down to 0. So we get 0.59. All right. There is another way that they can ask these. This says Kyle tosses a coin 10 times, so we have 10 trials. What is the probability that he gets tails? So 1/2 is the probability of getting tails. At least 8 times, so it would be 8, 9, or 10 successes. So this one, it would probably, because this is adding up, you have 2 options. You can do binomial PDF, straight up probability of 10, 1/2, 8, plus the binomial PDF of 10, 1/2, 9, plus the binomial probability of 10, 1/2, 10. You could add all those up. The other option is a little confusing for some students. You could say, I want to add up all the way to 7. I want the combined probability of 10, 1/2, 7, and that's the probability of it not happening. So then you would do 1 minus that. Okay, so what's the chance that it doesn't happen 7 times? All right. So if I'm doing it as a combined probability, sorry, it's binomial, not normal. I would want to say, still there were 10 trials and the probability was 1/2. And I wanted 7 or less. I want to add up all the probabilities of 7 or less, and I get this. But that's the probability that we would have 7 or less coins that came up tails. We want to know the probability of 8 or more. So we're going to do the complement of that, or 1 minus that. Now, if that's too tricky for you to understand, again, just do the binomial PDF, where you do 10 1/2 8, and you get that number, and then you do that again. Bring that down and make this a 9, and then bring that down and make this a 10, and then add those 3 up. Now they're very small numbers here. The bottom one looks big, but it's in scientific notation. There's almost no chance you get 10 out of 10. So it's a very tiny number. It's 0.00009, okay, that you would get 10 out of 10 tails. But if you add those 3 probabilities up, you will get the same as we did up here when we did 1 minus the combined. So we got 0.0546 or 0.055. All right, one more of these. The soda company prints prizes inside their bottle caps. The probability of winning is 1 in 3. So the probability of success is 1 in 3. Out of 8 bottles, so we're doing trials 8. What is the probability that at least 5 are winners? So you could add up the probability of 5, 6, 7, and 8. Or you could do 1 minus the combined probability of 4 or less, which would be out of 8, 1/3, 4 or less. Okay, so you could do PDF, but you'd have to add the number of successes at 5, 6, 7, and 8. Okay, so if you did it as a PDF, you wouldn't need the 1 minus, but you'd have to add up 4 different numbers. But if you do it this way, you can do it all at once. 1 minus the binomial combined probability of 8 trials with a probability of 1/3, and we wanted 5 and up, so we're going to add up 4 and down and subtract from 1. 0.0879. All right, on to some easy stuff. I should put a